Good morning, or good afternoon, or good evening to everybody, and thank you very much for joining today's webinar. My name is Richard Smith, and I'm Global Applications Manager at Taylor-Hobson. In this webinar, we will take a look at Taylor-Hobson's automatic LS-Arc auto analysis for spherical bearings. In the top right of the screen, we can see an example of a single bearing raceway, a double bearing raceway, and a situation where we have 4 arcs to analyze. In each of these cases, it's far better if we are able to precisely and automatically define the exact regions on the raceway that we want to analyze. This is often done in relation to the shoulders on the raceway profile. So using LS-Arc auto analysis to do this saves time and reduces the operator error. We're going to start then with an overview and demonstration of LS-Arc auto analysis. LS-Arc auto analysis is part of Metrology 4.0 software. It provides automatic analysis of spherical bearings by auto-detecting single or multiple arcs and shoulders. It auto-levels on the shoulders and can also auto-level on stepped shoulders, on stepped reference surfaces. LS-Arc auto analysis automatically extracts the precise region required. It can do this in different ways. Firstly, it can do it by defining the region for analysis in dimensions from the lowest point or from the highest point, that is from the turning point. Or it can do it by looking at the slope position on the curvature of the profile. Or it can do it as a percentage distance from the center. In these last 2 cases, using slope or percentage provides easy automatic analysis for a range of bearing sizes without the need to type in different dimensions each time. This can save a lot of time. Now for a quick demonstration of LS-Arc auto analysis on a single bearing raceway. So now we start the measurement in Metrology 4.0 software, and the first thing that we do is to select the single bearing. The measurement takes place, and just for this illustration, I've stopped the dialog box there on the screen. Normally this is automatic, but I've just shown what's happening there. And for this particular bearing, we're going to enter a particular region that we want to analyze. So we're entering 2 millimeters either side of the center. We press OK, and there is the final result in the contour analysis software. We can see the primary profile, we can see the radius, and we can see the roughness. We can also see those 2 points either side of the center. As well as this, the software has leveled the profile on these shoulders as well. Again, in Metrology 4.0 software, we'll look at a double bearing now, but this has double partial arcs. So in the same way, we start by selecting the bearing that we're looking at. In this case, it's a dual bearing raceway. And the measurement takes place. We can see that this profile is quite tilted. And if we look on the profile, we can see the shoulders on which we want to do the leveling, and we can see the partial arcs on the left and the partial arc here on the right. Again, we proceed with the analysis, where we can see the residual profiles for arc 1 and arc 2. So this time we're analysing 2 arcs in this same software. Here again is the full result in Contour software. We can see the primary profiles at each end. We can see the radius of each of the arcs, as well as associated roughness values on the arcs. And we've leveled the profile on these shoulders. So let's have a look now at some of the options and settings in LS-Arc Auto Analysis. Once we have the profile, we can open the dialog box, and here it is. And we can see the profile there that we've measured, and it's automatically leveled it on the regions marked in pink, and on the central section in violet, that defines the region that is available for analysis as an arc. And we've just chosen a very small section of that to analyze between these 2 blue dots, between the left fitting limit here and the right fitting limit here. Once that's complete, we will see the associated residual profile for that region that we've just analyzed. Another example here that we just looked at for the dual partial arc profiles. Again, in the dialog box, we have leveled on these 2 shoulders. These 2 regions have automatically been found as defined as being an arc, and we've chosen here the region for arc 1 that we want to analyze, and we've chosen this region here, a different set of settings for arc 2. Below it here, we're showing the residual profile for just arc 1. So now let's have a look at further capabilities using multiple arcs. We've already had a look at a single arc analysis and at dual partial arcs. We are also able to measure stepped arcs. As you can see here, we have the shoulders at a different height. And if the profile is significantly tilted, we'll have a look at how this is leveled automatically. And also we'll have a look at analyzing up to 4 arcs. So let's start with the single arc just to recap. And what we're doing here now is bringing up the dialog box for the LS-Arc Auto Analysis as before. And on the screen there, you can see the 2 areas on which we've done the leveling. We can choose to select both of them or either of them or none of them. That is the arc region there, that's the region defined as an arc, and the two dots there are plus and minus 1 millimeter from the center. 1 millimeter, now is changing it to 2 millimeters from the center, and you can see that those dots move out to -2 and +2 millimeters. And the result there is for arc 1. That's the residual profile between those two blue dots. We also have the ability to define a different arc analysis region from the region over which we've done the form fit. And in this case, the arc analysis region I'm setting here for 3 millimeters. And you can see two other dots there which define the region over which the analysis takes place. But the form fit is taking place between those two blue dots, between plus and -2. And the result there again is shown just for that arc. Once we click OK, we can see the profile has been leveled. That's the leveled profile there, leveled on those shoulders, and that's the residual profile. Looking now at a stepped double profile, again, we bring up this dialog box. This is just how we would set it up, and we can choose which regions we want to use for the leveling. Clearly, that's still tilted, so we choose the step function over there in the right, and we're choosing those two pink regions shown for the leveling at different heights, but it still levels the profile. There it is. The profile is leveled. That's the leveled profile now, you can see, and we have two results, one for each arc. And if we just go back up again, we can see that we have leveled on between there and there. Let's have a look now at a profile with significant tilt, in this case 4 degrees. Again, we bring up the dialog box, and you can see automatically, without doing anything, the regions for leveling have been detected. And we've leveled that profile. You can see it's leveled on that on those edges, and there again is the residual profile. If we look in the dialog box again, if we change the detect lines angled less than dialog to 3 degrees, then clearly that is outside the 4 degrees is greater than that. So what's happened here is that it's actually not leveled the profile. Let's have a look now again very quickly at those dual partial arcs. One on the left and the one on the right. Here is the analysis taking place, and we've leveled on those two shoulders. We've ignored the other flat regions in there, and we're looking at arc 1 residual, arc 2 residual, and both residual profiles there together. And so even though that profile has some tilt, it's now been leveled on those two shoulders, these two shoulders, and we can see both of the residual profiles coming out. Finally, let's have a look at the analysis, measurement and analysis of 4 arcs. And here's the dialog box again, which has automatically detected the shoulder regions. We can select or deselect the ones we want. And we're showing arc 1 as a residual. We're now choosing, let's choose another one. We can see the residual now for arc 3, that's there, and arc 4, and then all of the profiles together. So this is showing the residual profile now for all of the residual profiles being compared. So clearly a very powerful way of analyzing arcs. And once we press OK on that dialog box, all of those, you can see it's leveled the profiles, and then all of the individual results come through. Let's take a look at the contour analysis that's been done on that dual partial arc. As I mentioned earlier, we can see the form error, the roughness, and we can see the primary profile and the green dots there defining the analysis regions and the form fitting regions in each case. Let's look in a little bit more detail at that now. So we're going to look at this right-hand side where that green box is, and we're just going to zoom in on there and have a look. So there it is again. This is that area defined by the large green box, and what we're showing here is the left fitting limit is here, and the right fitting limit is over here. The left analysis limit is here, and the right analysis limit is here. What I want to show here is that the dialog box and the display you see in Contour are interactive. So as we change the numbers, you can see I've changed the number here to 2 millimeters and to 1.75 millimeters, and you'll see the position of these two now change, and you can see those have now moved in the contour analysis. And there it is in contour analysis with the modified positions of those arcs. The positions of those limits can be set automatically right from the start of the measurement program. They could even be part of a barcode read on a profile, on a part. So let's have a summary now of what we've seen today. We've had a look at automatic analysis of spherical bearings. We've seen how we can auto-detect single or multiple arcs and shoulders. We've seen how we can auto-level on shoulders and on stepped reference surfaces. We've seen how least squares arc auto analysis can automatically extract the precise region required with reference to the center of the arc. And this can be defined by dimensions in millimeters from this center, from the turning point, or by the slope or position on curvature, or by the percentage difference from the center. And as we mentioned at the beginning, in these two cases, using the slope position or the percentage distance provides easy automatic analysis for a range of bearing sizes without the need to constantly enter information. So that brings me to the end of the webinar. It's an opportunity now to have a look at some of the questions. So we don't have any questions today, but I'd just like to say thank you again and look forward to meeting you at the next webinar that we have. Thank you and goodbye.